Ever wondered how crucial database planning is in the development of any database-driven application? It's akin to creating a blueprint for a building, where each detail plays a significant role in the final structure. Database planning involves defining objectives and requirements, understanding data sources and flow, and assessing existing systems and data. But that's not all. It also includes determining the scope and architecture of the database, selecting the right database technology, and designing a data model and schema. And like any good plan, it considers potential challenges, like ensuring data security and compliance, optimizing performance and scalability. Furthermore, it focuses on establishing solid data governance and management policies. Each of these elements is a piece of the puzzle that, when put together, creates a robust and efficient database system. So are you ready to dive deep and explore these aspects in more detail? Let's delve into each of these aspects in more detail. Firstly, it's vital to clearly define the objectives and requirements of the database system. This is the foundation upon which all subsequent planning and design decisions will be based. The purpose of the database system should be identified early on, along with its intended use. Are you looking to improve data access, ensure data integrity, enhance performance, or support specific business processes? These goals and objectives need to be clearly defined. Then, it's time to gather requirements. This involves talking to stakeholders and understanding their needs, including data requirements, functional requirements, performance requirements, and security requirements. These requirements provide a detailed picture of what the database system needs to do and how it should perform. The importance of this step cannot be overstated. It ensures that the database system will meet the needs of the users and the business. With clear objectives and requirements, you can ensure the database system meets your needs. Next, it's important to understand the sources of data and how data flows within your organization or application. This understanding forms the backbone of your database planning. So where does your data come from? It could be internal systems, external sources, user inputs, or even sensor data. Each source has its own characteristics and requirements that you must consider. Now let's talk about data flow. It's all about understanding how data is created, captured, processed, stored, and consumed within your organization or application. Just like a river, data has a starting point, a flow, and an ending point. Knowing this flow ensures that your database is designed to accommodate and streamline this journey. By identifying your data sources and mapping out the data flow, you'll gain a holistic view of your data ecosystem. This will guide you in designing a database system that truly serves your needs. Understanding data sources and data flow can help you design a more effective database system. Another key aspect of database planning is assessing any existing systems and data. It's important to take a close look at any databases, systems, or data repositories that you're planning to integrate with or migrate to your new database system. This will give you a clear understanding of what you're working with and what needs to be done. Assessment isn't just about looking at what's there, it's about evaluating the quality, accuracy, and completeness of the existing data. You need to determine whether data cleansing or normalization is required. Data cleansing is the process of detecting and correcting or removing corrupt or inaccurate records from a data set. On the other hand, normalization is a method of organizing the data in a database to reduce redundancy and improve data integrity. By assessing existing systems and data, you can identify any issues that need to be addressed in the new database system. Once you have a good understanding of your data, it's time to determine the scope of the database system and define its overall architecture. The scope of your database system can be determined by factors such as the number of databases, the size and complexity of each database, and the intended users and applications. You might be dealing with a single centralized database or perhaps a series of interconnected databases across multiple locations. Defining the overall architecture involves deciding on the types of databases you'll be using. This might be a relational database, a NoSQL database, or a combination of both. You'll also need to consider data distribution. Will data be stored in one place or distributed across multiple locations? How about replication, clustering, and backup strategies? These are all crucial in ensuring that your data is safe, secure, and accessible when you need it. A well-defined database scope and architecture can ensure your database system is structured effectively. With the database scope and architecture in mind, The next step is to select the most appropriate database technology. Here's where the rubber meets the road. This is where you get to leverage your understanding of the project's requirements and the data at hand to choose a database management system that best fits your needs. When evaluating different database technologies, consider factors such as the data model. For instance, will your data best fit a relational, document-oriented, or key-value model? Also, consider the scalability of the technology. Can it handle the data volume you're expecting now and in the future? Performance is another key consideration. How efficient is the technology in handling queries and transactions? Don't forget to weigh in on the security features the technology offers and its licensing costs. Remember, the chosen technology should be compatible with your existing systems and within your budget. Selecting the right database technology can greatly enhance the performance and functionality of your database system. The next crucial step in database planning is designing the data model and schema. This process begins with translating the identified requirements into a structured design. The data model defines the logical structure of the data, detailing how each piece of information relates to others. It's a blueprint that guides us on how to organize our data effectively. To design the schema, we first identify the tables, columns, relationships, and constraints. Tables represent entities or objects, columns represent attributes, and relationships represent the connections between these entities. Constraints are rules enforced on the data, ensuring its accuracy and integrity. Next, we implement normalization, a technique that aims to minimize redundancy, eliminate irrelevant data, and improve data integrity. This process involves dividing a database into two or more tables and defining relationships between those tables. A well-designed data model and schema can improve data integrity and make the database easier to use. It's like having a well-organized library where every book is easy to find. Now that you have your data model and schema, it's time to plan for data security and compliance. The first step is to identify your security requirements. This means designing appropriate access controls, authentication mechanisms, and encryption methods to protect sensitive data. It's also crucial to incorporate auditing features to track and monitor data usage. But security isn't the only concern. Compliance is equally important. This involves understanding and adhering to the relevant regulations and standards in your industry. Whether it's the General Data Protection Regulation, Health Insurance Portability and Accountability Act, or the Payment Card Industry Data Security Standard, each carries its own set of rules for data privacy and security. Implementing these measures not only ensures your database system is secure and compliant, but also helps to prevent costly penalties and damage to your organization's reputation. Remember, data is a valuable asset, and it deserves the highest level of protection. Effective planning for data security and compliance can protect your data and prevent costly penalties. Performance and scalability are key considerations in database planning. When we talk about performance, we're referring to how quickly a database can process queries and return results. This can be optimized through the design of efficient queries, indexing strategies, and database tuning parameters. On the other hand, scalability is all about future-proofing. It's about designing your database system to handle increasing volumes of data and users over time. Whether it's scaling up, which involves adding more power to your existing system, or scaling out, which involves adding more systems to your network, a scalable database can adapt to growing demands without compromising performance. In a nutshell, performance ensures your database system is fast and responsive now, while scalability ensures it remains so in the future. By considering performance and scalability, you can ensure your database system can handle future growth. Finally, it's important to develop data governance and management policies. These policies are crucial for ensuring the quality, consistency, and usability of your data. Data governance policies provide a framework for data stewardship, defining who is responsible for various aspects of data management. They also establish standards and procedures for data quality, data privacy, and data security. On the other hand, data management practices concern the practical aspects of handling data throughout its life cycle. This includes how data is created, captured, processed, stored, and consumed. It also covers data retention policies, data archival, and data backup and recovery procedures. Remember, these policies don't just protect your data, they also protect your organization. By ensuring data integrity and security, you safeguard your organization's reputation and compliance status. Well-defined data governance and management policies can ensure data quality, consistency, and usability. And that's what effective database planning is all about.